Good afternoon, everyone. Welcome to May's First Friday webinar. My name is Katie, and I'm the Associate Director for ISPE. I will be your moderator today. Our topic this month is using laser scans in project development best practices, and our speaker is Chris Hahn. He has over 23 years of experience as an engineer and consultant. As a consulting engineer, Chris assists owners and contractors by providing engineering services for industrial and commercial projects. Areas of experience include laser scanning, HVAC design, dust collection, piping and pipe flow, and other mechanical engineering services. I do have just a quick few announcements. The quiz can be found on the usual webpage, and there is a link for you to follow from your confirmation email. I'm also going to paste it in the chat box for you during the webinar. There are no handouts for this presentation today. If you have a question for Chris at any time during the presentation, you can type it in the question box and we will read it aloud as we go along. And we will also reserve time at the end for questions. With that, I'll hand it over to Chris.
All right, thank you. Well, it's great to be here and great to have the opportunity to talk about laser scanning. This is something I have had a passion to talk to my colleagues about and owners about for several years. I got into laser scanning about in 2012, and so I dipped my toes into it at that time. And after doing my first couple laser scans, I was hooked. And so today, I want to talk about using laser scans to develop as-built drawings, using laser scans to get as-built measurements, and maybe you're not using it even for doing a whole drawing, and then using it to develop 3D projects, 2D projects, and then there will be some other details that I go into. So if you have some questions, please do feel free to type those in. Now, one of the reasons I like talking to people about laser scans is they often have an idea that in order to use a laser scan properly, you have to invest heavily in a lot of CAD extra training for computer-aided design, that you have to model everything in 3D if you get a laser scan, and that there's just going to be a lot of overhead to making it useful. And that's one of the main things I want to get across today, is that there's many times where a laser scan can be beneficial and used even though you're not modeling in 3D. We'll talk about those times where modeling in 3D, modeling in 2D are very beneficial, but there's many. This is a laser scan can be just as beneficial without a single bit of modeling being done. So as I go through and I discuss this, I just want to stress, I'm not what I would consider a CAD guy. I use AutoCAD and other CAD tools. I'm familiar with SolidWorks, I'm familiar with Inventor, I'm familiar with Autodesk BIM products, Navisworks, but I'm not a CAD guy. So I've directed and taught CAD guys how to use laser scans, but when it comes, if you hear something and I say, well, you know, and then I get my CAD guy to do this, I may not be able to, you know, this is not a teaching forum where I'm going to say and do it exactly like this, because a lot of times I'll just say, well, my CAD guy can do that, or a CAD guy can, and I'll show him to do that. I am going to show some laser scan software. I'm not a software developer, so I'm not necessarily saying you should use this piece of software. This industry changes often, and it improves often. And so that's one thing to know. And I have used laser scans to develop nearly 100 different projects. And so that's where I'm going to be speaking from today. And I hope to remove some of the mystery from using laser scans and give you the courage to try it on a project. So this first, I'm going to show you an area. This is an industrial project that I was asked to go and look at. It's several states away. And as I start this, we're just going to look around. And this is a video of the laser scan. Oop, I see it's not changing. You're not seeing the video, are you, at this time, Ariana?
No.
Okay, just one moment. It should be, because I've got both screens up. Let me just make sure that we're, there we go.
Now they're advancing.
All right, so there were my questions. There's where I'm going to be hitting. I apologize for that, guys. All right, so this is an industrial location, and in this particular case, we were looking at these two trusses. This particular truss right here, where you can see the bent had already been condemned, and so we needed to get measurements on this truss, as you'll see, but we could not go on the truss. And so as I run through this, so you can see here's the truss right here. And so the view I'm looking at right now is, some call it a bubble view, some call it, there's different names for it. But one thing you can see is I just passed over, I made some dimensions. You can measure with this. So I'm just, as you look at this scan, each scan location you can scroll around and look 360 degrees. Now what I just did was, right here you can see that there's a laser scan position, and up here on this, in this area right here at my top right of the screen, each of these circles are locations where I took a scan. And so this, where the video, I'm going to start it back up. I'm standing at the top of the building now, and where you see that blue is where I'm going to be going around and scrolling around, and you can see the direction I'm facing compared to the rest of the project. All right, so now we have the truss that has been condemned, and the steel specifically is what I was looking at in this case. One thing I want to mention is that one of the neat benefits I found of doing a laser scan is all the data that I gather that I did not know I was going to need. I have found that my memory of how something looked often fails me, no matter how many pictures I've taken of a particular subject or a particular building. I very seldom get all the pictures, still pictures, that I need. And so this is one area where a laser scan can be tremendously helpful. And so very often, if you scroll around in the laser scan, I've found that you can take then screenshots of the areas you need. And this often happens while you're developing a project. If you take the laser scan at the beginning of the project, then you can continue to develop the scope while you're back at the office.
Chris, we did have one quick question come in, and they're asking, what are the white spheres for?
Okay, so what are the white spheres for? All right, great question. So you'll see white spheres like this right here as we go through and look at the different scans. This white sphere is how you knit this laser scans together. So each of these laser scans are taken independently, and each time you take a laser scan, you want to have, typically when you're doing a laser scan, you put out 12, maybe you're working with 12 of these spheres, and so the goal is to get at a very minimum 3 spheres in each laser scan that overlap forwards and backwards. And those 3 spheres then are how, from a computer model standpoint, that's how we cause the laser scans to be knit together. And so we can get a composite point cloud, and I'll show you a point cloud in a little bit, but we can get a composite point cloud using those spheres to put the data together. All right, so this white sphere that you see actually in the scan, that is typically that's a piece of taking the data, and then if you see the white areas where I jump, call it hyper, do a hyper jump in the scan. If I click on one of these buttons here, then that's actually a piece of what's called registering the scan. All right. So we're going to move on. So using the first level of using a laser scan is you can get accurate, easily accessible data. The data is very usable, it's very repeatable, and the very first level of using a laser scan is done not with CAD, but using a software called Autodesk Recap. And I'm just going to pull that in here. So this is the program Autodesk Recap. And so what you're seeing right here is a point cloud. And so I can rotate this data around, and then you can see I have taken some dimensions in here. But the very first level of using a laser scan is I would tell somebody that if you're doing a remote project and it's more than a short distance away to get to the project location, then a laser scan can pay for itself very, very quickly. Laser scans can be had for in the neighborhood of, I would say, $4,000 for a short one-day scan, up to, I'm not going to put an upper limit on it, because obviously if you're scanning for 2 days or you're scanning for 2 months, those are going to be different. But if a typical industrial project where you're working in one location can be had in a day, maybe 2 days, and so that's, you're looking, most of the laser scans I've been involved in are in the neighborhood of $4,000 to $10,000. So that kind of gives you an idea. And when you think about having accurate, easily accessible data, usable data, and repeatable data available at your fingertips at your desk, then so where I see the scans paying back most often is, and I'm going to use if anyone out there is a Dave Ramsey fan, Dave Ramsey is the money guy on the radio, and he always tells people, if you are having trouble making a decision, it's often because you need more information. And as an engineer, there's many times where if I don't have a laser scan and I'm stuck and I'm ready to finalize my design, but I know that I just can't do it until I make that trip. And so, because I can't see it in my mind, I can't remember exactly how it went together. And so I've had to make trips across states. I've had to make trips, take a plane trip. And so all those add up very quickly. If you add up a trip, one-day trip on a plane, somewhere, you're looking at $2,000 to $3,000 for a trip. And by the time it's all said and done, and if you can get a laser scan done on that first trip down, or have somebody go out and take the laser scan for you, then you have a piece of data that's usable for the whole period of the trip, and it's usable by more than just yourself. So if I take a trip, I get the data in my mind's eye, but if I get a laser scan, then I can convey that information, or other team members can use that information and reduce the number of on-site trips tremendously. And that's where I see one of the big paybacks on laser scans. All right. Now, what I'm showing here is a 2D plan view. And actually, so the way this 2D plan view was developed, I'm going to go back here. The way this 2D plan view was developed was, I'm going to show you the point cloud, and I'm just going to rotate this particular point cloud around. And then I took a very thin section out of the building. And so you can see that there's building columns. I can cut right through the building columns. And I can cut through pieces of equipment right here. I can cut through some conveyors right here. I can see the front end of a conveyor and the front end of a conveyor here. And so these are my work points, and I'm able to develop them in a 2D fashion and in an elevation fashion very accurately. So, and this is done in AutoCAD. So again, this is a 2D model. It doesn't require any modeling, 3D modeling, and I'm able to use different coordinate systems in AutoCAD so that I can use an elevation or plan views. So, all right, so I'm going to just let this go forward. Now, as you're at the beginning of using scans, you'll see that these points often feel like, it looks like, well, how are you seeing anything here? And as you start using a laser scan, the points can sometimes feel unclear, but it's like watching 2D, or especially if they're in black and white. Sometimes it's like watching black and white TV versus color TV, and so the definition doesn't, when you first come into it, it doesn't feel like it's easy to see, but then you start getting used to it. What you're seeing is every time I touch one of these spheres, you actually get an image up here of what that laser scan was looking at. Now I'm kind of moving around this particular laser scan, and let's see, let me move forward just a little bit. Oh, okay. So what you're going to see, so what's happening right now, I'm going into the bubble view, or the 3D view. All right, here we go. So this is pretty cool. So now you see we were looking at the cloud and that cloud is very it takes some getting used to use. And let me say, when you're using AutoCAD and the scan is in AutoCAD, that kind of that granular picture is what you get. But when you're in Autodesk Recap, then this is the image you can get in the 3D view. You can get both views. You can get the laser scan granular, and you can get this photorealistic view that you can rotate 360 degrees. And so you're seeing, I've taken a few dimensions here, and you're going to see me take a dimension in just a moment. All right, so I'm going to reach down. I'm going to grab the distant measuring tool. Now, everywhere you see this disc, you see it rotate on a flat surface. So that's where I'm going to take my measured surface. All right, so now I'm just going to take a dimension from one column to the other, and I'm not going to be very careful about it. And what you're seeing here, let me just stop right here. What you're seeing is this scan is set up on an X, Y, Z axis, and so I'm actually, in this case, it's showing me the Y dimension. It's showing me the Z dimension up and down, and it's showing me the X dimension. And so you can see that the hypotenuse of this measurement is not accurate at all. I'm just pulling from one column to the other column, but in my Y direction, it's accurate, because all I'm doing is I'll say north and south. And then in a Z direction, where I happen to hit on this column and where I happen to hit on this column is 1 foot 4 1/8. You can put this in meters, you can put it in millimeters, you can put it in whatever type of dimension you want. And so you can measure these dimensions. And I have done whole projects working with engineer. I have an engineer that I do a lot of work with. He's a designer in Iowa. I'm located in Decatur, Illinois. And he is an excellent CAD technician. He is at a place in life he does not want to learn how to pull the AutoCAD or the recap files into Autodesk in AutoCAD. And so he and I will Skype. He'll tell me, he'll say, look, tell me, get this image in front of you. Now make that measurement. And so I can make the measurement very, very accurately. And we've done projects like that for him, because he wants to he only needs a few dimensions to make the project work. And so the laser scan saves us a trip down, and we can get it very accurately, and we can do it over Skype. All right, so that's it. Now, what I'm going to do in this next video, I'm going to show you how I did that 2D file. So, okay, I think this is the same one. I apologize. So let's see. Let's go here. Next. All right, here we go. All right, so I'm back into the point cloud. I'm going to zoom out of the point cloud. I'm going to clear. You're going to see the whole building for a moment that was scanned, not just this one little section. So I'm pulling out. You're seeing the whole building that I scanned. It's of the industrial plant. Now I'm going to take a thin cut through the building. And so you can do this, I'm turning perspective off, you can do this from an elevation standpoint, or you can do this from a plan view. So very thin cut, and the the better detail you can get. Then up here, I'm going to just turn to the top floor. And so now I've got my plan view. And you can do this in AutoCAD also. And let's see here.
Hey, Chris, I had another question come in.
Yes.
The chutes shown, can you scan well enough to establish bolting flange hole patterns?
Yes. Yeah, so like this bolting pattern right here. So I do have a drawing where you can actually scan it. You can. It's not difficult actually. You can scan it well enough that you can get the bolting pattern off of it. And at a minimum, the work point is very clear. And so the short answer is yes, you can do that. And I've done it. So, all right, let me move forward in this. Now, what we're going to see here is, okay, so I'm zooming in to one of these I-beams, two of the I-beams. So I've zoomed way in. And one of the cool things about doing a laser scan is you can actually make measurements that are not possible in the field. So here's one of those type of measurements right here, where you can measure the flange thickness using the laser scan. So, the web thickness. The flange thickness you can always measure, but you can also measure the web thickness if you get a scan from both sides. And this can be, and is accurate enough that you can use it to determine what type of I-beams these are, height, width on your flanges, and even your thicknesses, that you can be comfortable using those for design to understand what you have.
All right, I do have two more questions.
Yeah, please.
One of them, if at some point during the presentation, can you explain how you obtain laser scanning equipment and how much it costs? And then the other question is, how do you decide how many scans to do in order to get the proper imaging?
Perfect. All right. I'll address those. Great. Those are both good questions. And so actually, let's just talk about. We can talk about. If I go back here, on a very simple aspect of a project, when you laser scans do not look through walls. Laser scans have a point of view. So if you are in people use laser scans outdoors, for instance, to measure maybe the face of a building. And so there's no obstructions and there's a wide open space. And so if you are standing in a location and you can see all the details that you need in a image, then that's awesome. That's great. But if you know that you're going to need, if you're standing in this, like this is a location that is very, very congested with a lot of equipment. So you'll notice that I actually moved the laser scan throughout this location under some of the equipment and around this space, because if you want, you have to be able to, you have to move the laser scan so you can get your, you can get your eyes on the material, then you can actually, then your laser scan is going to pick up the same details. And so that's really, it comes with practice, but, it comes with practice, but the main thing is, if it's a wide open space, if you have a warehouse with nothing in it, then you can see most of the building in 2 or 3 or 4 or 5 scans. If you are in a congested area and you want the details of that congested area, then you have to look at your line of sight and determine how many scans you're going to, you walk from each position and say, okay, am I getting the details I need for my design? And so then you make several, as you're doing a preliminary walkthrough through your project, and you talk to, if you're running the project, then you will tell the technician who's taking the laser scan, I want this, I want this, I want this. And so if you're the person on the side of telling a laser scanner what to do, that's how you're going to act. If you're taking the laser scans, you need to ask the question, what are the priority areas that you're going to be using for design? And so then the technician will be sure to focus and take more scans in that area. So, all right, I'm going to move forward.
One more quick question, Chris. Can you confirm the brand or the model of the scanner that you've been using?
Sure, I will. So when I started taking laser scans, and so this will, let me stop this. When I started taking laser scans, I started using a Leica scanner. And so this was, I'm going to say, so 2012, so we're talking 7 years ago. And the Leica C10 scanner at the time, when I first started using it with targets, I could get 12 scans per hour. No, 12 scans per day. 12 scans per day. It took it took time to set up the targets, and we were at 12 scans, 12 to 13 scans per day. Then I started using a Faro laser scanner, and that Faro laser scanner, I was able to get up to 25 scans per day. And so then with the newer model Faro scanners, I was able to work my way up to approximately, I have done scans where I've been able to do 70 scans per day with the Faro scanner. And in industrial situations, the reason why that works is I turn down the level of points each scan takes, so that each scan takes about 2 minutes. I turn off the color imagery, so that, because color pictures can take, the scan can take 2 minutes and the color imagery can take 5 minutes. And so I turn off the color pictures, and then I take the laser scans. And so I've moved through now where I can take between 50 and 70 scans per day. And you can cover a lot of ground. In an open space, the laser scanners are capable of going between 200, 300, 400 feet. And so most of my scans happen in industrial situations, so I'm actually moving the scanner probably only 10, 20, 30, 40 feet at a time. And so it's better to take more scans with less density, and you'll have smaller files also. That's not to say these files will be small. It's to say that so a laser, that's one thing, laser scans are fairly sizable, and we'll talk about that a little bit. Okay, so the new Leica software, actually the new Leica scanners, I just want to say, because I'm not married to a brand. The new Leica scanners can do a scan and pictures in 1 to 2 minutes. And they're very good, very accurate, and they've caught up and in some ways surpassed what the Faro scanners have been doing. And so my expectation is that Faro will come out with a new one soon, and they will do that. So I have not yet purchased a laser scanner. Even with the number of scans I've done, I have found that unless you use the scanner on a very regular basis, unless you're a fairly sizable company and it's just the cost of doing business, then the cost of renting the laser scanner is it's generally $1,000 or less per day. And so unless you're having that laser scanner work 80 or 90 days per year, then it doesn't make sense to me to purchase a scanner. I would rather rent the latest and greatest technology for $1,000 or less per day than I would have a scanner that gets old in 2 to 3 years. So.
Hey, Chris, I had one more question come in, if that's okay.
Yes, please.
All right. Let's say one of the panels shown in the shoot needs replaced and no drawings are available. The location of the panel prevents easy hand measurement. Will this method allow accurate shop fabrication drawings to be made for fabricating a new panel that will absolutely fit up perfectly?
So, without doing, the short answer is I have done that type of work many times. So the answer is you can get there, yes. And I'm not going to say that every scan taken will give you the detail that you need. But if you go in with that in mind, that that's what you want to do, then yes, you can get that level of detail. Often I do this in Class 1 Div 2 areas or Class 1 Div 1 areas where I take the laser scanner in, I scan. The equipment is not Class 1 Div 1 rated. Typically, there is one you can get, but it costs a lot more, and it's bulky and hard to use. But you can often use a sniffer and just measure the level of explosive material in the air, and most companies will let you go ahead and take the laser scans. Now, what I'm going to do, I'm going to actually, since I've got about 10 more minutes before I'll open it up for the final questions, for now, I'm going to go ahead and finish. I've got a few more slides and a few more details I want to get out in the last 10 minutes. And so I'm going to hold the questions until the end. So right here, I'm just very quickly kind of going through. I'm zooming in. You're seeing in this 2D view where again, you asked about the flange earlier. There's that work point, the flange point. I did not show the bolt holes, but if that had been a request by the owner, I could have zoomed in and got the bolt holes for those flanges right there. All right, so what I want to do is I want to switch to 3D design. Now, some of the 3D design, and what I want to talk about a little bit is middleware. So middleware is what I'm going to talk about. Is the definition for me for middleware is software that is not your laser scan and it is not your CAD software, but it is there to help you pull models out of the point cloud. One misunderstanding many people have is that if you get a laser scan, it's going to be super easy to just, you push a button and everything is going to model up and it's great. And so let me just pop that bubble right now. Boom. There is still work to be done. You can make this work 8 or 10 times faster by using a laser scan. You can make it more accurate by using a laser scan, but there is still hard work of doing CAD and engineering involved in a laser scan. And so I just want to say that right up front, that doing a 3D model is not simply push a button and let it go. I'll show you a piece of middleware that is easy to use. There's one by Leica Cyclone. There's a Clear Edge software. There's LFM software. There's some actually AutoCAD is not what I would consider a middleware. But it's a piece of software that helps extract the data. And so let me just show that. I'm not sure why. Oh, I get it. Okay, there we go. He's looking at my screen. So this is Clear Edge, and so here when you run Clear Edge, you can often pull out 70% of the pipes automatically, and then you have to do some hard work of verifying that those pipes fit. And then you can pull the structures out, and I'll just go up here. So we're pulling some structure out, and let me go to, oh, here we go. All right, we'll go from here. So this is a model that's being pulled from the point cloud, and this is edgewise. Now right here, what I'm doing is we're fitting BIM models to a point cloud. This will automatically connect pipes. So now you're seeing the point cloud, and then you're seeing in orange you see the BIM model, and in white you see the gray. All right. Here's an example of how to extract the data. So again, it's not 100% automatic, but you can tell it, I know this is an I-beam, fit an I-beam to the point cloud. And then you can take that and you can stretch it and you can move it across your different point cloud. So this is a point cloud that's done to some standing steel. And so this is fitting I-beams, structure, and so then you can pull this into Revit, you can pull this into AutoCAD. So it still takes work. It's not 100% automatic, but it's really cool because you can be sure you know exactly where these beams are. All right, so. Okay, so then, all right, a couple things I want to address when you're asking for a point cloud. One of the datums, and this was pretty important to think about before you get a laser scan. So some people want to go and they say, well, I want to have all my data to the state plane. And if you get when you put your point cloud together, you're going to have to move it in space to a location. And if you use the state plane as your location, that will come up, when you bring your point cloud up, it will come up exactly as it is in real life. The downside of going to state planes are AutoCAD in particular. There may be some other software that handles state plane really well. AutoCAD does not handle state plane data. The millions, its coordinates in the millions, instead of like 10 foot or 10 foot or 100 foot or 1,000 foot. So you're in the millions. AutoCAD, I'll just say it chokes. So if you're using AutoCAD, do not get your point cloud registered to state plane. So then you have to decide, do I want to go to a plant datum? If you have a plant location, it's often good to have a plant datum, and that's usually you want to ask that question up front. This will probably add about $1,000 to the cost of the laser scan, because you have to have someone come out and survey the points you're scanning, and then the point cloud is registered to that. The benefit of that $500 to $1,000 you get is if you take multiple points around the plant, then your laser scans are registered to that plant coordinate system. And finally, my recommendation is if you've never done a laser scan and you just want to get it started and you're not sure if this plant is ever going to do another laser scan, then you can just ask the guy who's taking the scan, or the company that's taking the scan, to register it to a project north. That means your coordinate system picks some area that will be 0, 0, and put north, north, or put your project north. So if a building is maybe it's cockeyed in space, maybe you want to rotate it so that its north is project north. And that's done for, I would say, 50% of the projects I do, because you don't have to survey, and if you don't expect to go back to that plant again, then you're not expecting to have to fit laser scans together. But if you're working for a large, Fortune 500, Fortune 30 company, something like that, you may say, we're going to do a lot of this laser scanning, and so we want all of these laser scans to fit together. And so that's where you want them registered to a plant datum. So that's really important, and it's an important thing to think about. And then just different pieces of software when working with things to think about. One is these files are large. A small laser scan is about 8 gigabytes. A large laser scan that I've worked with is in the neighborhood of 500 to 800 gigabytes. And so my recommendation is, if you're starting out, to get a RAID drive, a redundant array of independent disks, and use it like a local drive, and get 4 or 5 or 6 terabytes put into it, and use that locally. If you are with a bigger company and you have plenty of resources, the only way to use a network drive is it has to be connected by a fiber optic. If you're trying to do network over anything but fiber optic, it's probably not going to work well. So that's something to just keep in mind. Let's see. Different pieces of software. These are just Autodesk Recap. You can get it for free to download and test. You can get a viewer that will stay active for free from Autodesk. You can get the pro version, costs it's whatever, you have to find out what that costs. But you can actually use the viewer for free. AutoCAD, you can pull these laser scans into AutoCAD. I haven't shown it today. If anyone wants to see more, you can contact me. But AutoCAD in the past 5 years has gone very, very far. It's very simple to pull a point cloud in. There's a button to do it, and it takes about a minute. Navisworks is a great way to view your point cloud with your other CAD drawings. And you can use a lot of different CAD versions and a lot of different versions of models, BIM and such. ClearEdge Edgewise, probably my favorite tool, middle tool. Leica software, family of software. Lecacyclone, I'm sorry. That is a set of tools that are, they work very well. There's a little more, let me just say this, there's a lot more investment. That investment may go anywhere from $50,000 to $100,000 to get the whole suite of tools to use. And so that's one of the reasons for people starting out, I recommend going towards Autodesk Recap and AutoCAD, because most people actually already have those tools. LFM, very similar to Cyclone. I have only used it very seldomly, but I know that there's a group of people that use LFM tools often. And then last but not least, I don't know if you guys are familiar with a tool called Snagit, but and a PDF editor. Those are really useful when you're using this type of software. And I'll just show you why. If you have something like this, Snagit, it's like a screensaver or video saver, but you can pull this piece of software up and easily go in, take a screenshot, pull it over here, and now I can mark up the areas I'm looking at, and then I could copy this out and put it into an email and send it off. I use this tool all the time. Another tool I use often is Tracker software. It's a PDF editor. So I'll just, it's a PDF editor. What I like about this particular tool is they have a neat little tool in here where you can measure distances. And so let's just say we knew that that roof was 100 feet. You can come in here and boom, put in 100 foot. And let's just say actually it's also 6 inches, 100 foot 6 inches. And now it's calibrated, and so now you can go in and you can get a pretty good measurement on your PDFs. Super useful tool. I just threw that one in there for free. All right, so let me see. I think that's, we're ready for questions. And oh, one other question. One other thing I did need to bring up before we go to questions. Oops, sorry. Let me very quickly go through this. I showed this screen, but I didn't speak about it. Level of detail. When you're having someone model for you, this is a document that you can get from the BIM forum, level of development or level of detail. This is also one, level of accuracy, and how accurate your scan is going to be. Most laser scans we can get within this 5/8 to 1/4 inch range. That's where your level of accuracy typically is going to be with the scan right here in this 1/4 inch area, unless you're going out to 300 or 400 yards. So this is, you want to know what level of accuracy they're going to scan it at. So ask that question. The other one is what level of detail if you ask someone to model for you. My recommendation for most models is aim for 200 to 300. This is your level of detail. It gives you enough that you can see the shape. It's not just an envelope, but you're not getting down to the nuts and the bolts of everything. Doing the nuts and the bolts is going to cost your make your model cost 3 to 4 times what you can do if you do a level of detail 200 to 300. So same thing if we're looking at architectural, same thing if we're looking at MEP. Most of the MEP projects I do, this level of detail 200 is good enough. Every once in a while, people want a a model that shows a few more details. Very seldom do people want a level of detail at 350 where you're actually able to see the shape of the valves and all the little handles on the valves and such. All right. So other questions now?
Yes, we've had a few come in, so we might have time for those of you who haven't asked a question yet. But if you'd like to ask one, please type it in the question box, and we will do our best to get to it. And real quickly, I just want to remind everyone to please be sure to complete the quiz by next Monday so that we can get those certificates out in a timely fashion. So with that, I'll proceed to the questions. The first one is, does AutoCAD extract data from a laser scan?
So AutoCAD extracts some data. It's a small amount of data. So AutoCAD has the capability. So let me just say it like this. AutoCAD by itself has the ability to find, I'll call it the straight lines. It has the ability to find, if you have two walls, it can find the intersection of that two walls. So that's what it can find. It does not extract a full wall. It does not extract 3D data. So AutoCAD by itself does not. AutoCAD has a new piece of middleware out there that they purchased from another company, and I don't remember the name of it off the top of my head, but they do have an a feature extraction software. But it is not just AutoCAD. It's a middleware piece of software that is made to work directly with AutoCAD, and it's a great tool. I have not used it since it's been 100% integrated with AutoCAD, but they do have an add-on software that you can do that. It's similar to ClearEdge Edgewise, but it is more geared towards one-off pieces of equipment instead of fitting to pipes and structural members.
All right, thank you. The next question was, what is RAID? R-A-I-D.
Oh, RAID? What is RAID? Yeah, so a RAID drive is a redundant array of independent drives. So for under $1,000, you can buy a RAID drive. And so my RAID drive has four 4-terabyte drives in it. And with those four 4-terabyte drives, it gives you the ability for any one of those drive, and depending on how you set it up, any one of those hard drives can crash. You can pull it out and replace it with another hard drive, and it will rebuild itself. So when you're dealing with someone else's data, when you're dealing with your own data that you've paid $3,000 or $4,000 for or more, you want to have some sort of, you always want a backup set of that data, but when you're working with the data, it's best practice to have a RAID drive so that when your hard drive crashes, because we all know nowadays they will crash, then it's a best practice to have a backup so that you can stick another drive in there and just keep going. So if you look up RAID drive, you'll find it. And there's lots of them out there.
All right, the next question was, do you prefer to model the details in the laser scans or not?
Yes. It all depends on my customer. I have customers that they want to put in piping during a shutdown into a Class 1 Div 1 area. There is no question they want 100% of it modeled, and they're willing to pay for that. So so, you know, it's cheap to spend $5,000, $10,000, $15,000, or in one case I did a whole building, 4 stories, at $35,000, and so it's cheap to do that, relatively speaking, if you have to if you have a critical piece of equipment and it's got to be right. On the other hand, I have my other designer I work with, he just wants to know that he's got it right. And so he calls me up and we Skype in the morning. He said, pull up the laser scan. He said, I want this dimension. I want this dimension. I want this dimension. So I give him those dimensions. He goes on and he's happy as can be. He does not want a model. He doesn't want to learn how to use a model. But it still saved both of us 3 or 4 trips, you know, plane flights, because we have the laser scan. So it's already saved money. And you can save money on both sides of the spectrum, whether you model it or don't model it. Every project, you have to ask the question, do I need it?
Thank you. We have 2 more questions, so I'm just going to go ahead and address both of those. I know we're a little bit late, but thank you everybody for sticking around. The next question is, what do you use Autodesk Recap for again?
Okay, so Autodesk Recap is just that it is in my opinion, I'm showing it here on the screen. It's the best tool to move around, and I'll call it, you know, you don't have to be a CAD person. You don't have to be. It's the best engineering tool for using laser scans. And now I can clear that. I can go to real view, and I'll just do this very quick. So as it's going, and so it's a great way to interrogate your scan without being a CAD user. And so that's what Recap is. And here I'm doing this live. So I'm always careful not to do something live but everything seems to be working today. So I'm doing this live, and you can see I can look up. I can go all the way to the ceiling. I can see the trusses in here, and I can move around with this Recap. And everywhere there's a little ball, then I can move over to that. So I'm going to go to the end of this truss. I'm going to just zoom over there. Now look here. So now I'm looking back. Where I was standing was right over here. And so now I have a totally different perspective on what I'm looking at. And I can go in, and here's an area where I did count the bolts, and we did get the bolt pattern off of this flange. This is the working point that you saw in my 2D drawing right here. And I can measure the steel here. And I'm not a CAD guy, and so I can do this as an engineer. So it's a very, very user-friendly technology. Okay, go ahead. Last question.
All right. Do you recommend getting RAID since the very beginning?
So what will happen is you won't have a RAID drive. You'll get the laser scan. Probably it'll come to you on a terabyte drive. And you'll start working on the terabyte drive because you don't want to use all the terabyte. You know, you have a 1 or 2 terabyte hard drive on your computer, and you decide, I don't want to fill up that terabyte drive on my C drive. And so you start working on the external terabyte drive that was sent to you with the laser scan on it. And then you say, gosh, I should save this off somewhere. Then you say, I need that external terabyte drive for my next laser scan. And so the long and short of it is, you're going to either get a RAID drive of some sort, you're going to get a large capacity hard drive, external hard drive, or you're going to have an IT department that's backing you up that can say, yeah, let's get 10 terabytes of memory available. Let's back it up to a Google Drive, or let's back it up to a Amazon encrypted drive, or something like that. So my opinion is, yes, you're going to get a RAID drive if you don't have a large IT department behind you. So if you do, you're going to get what they said you get. Go ahead. That's it. Thank you, everyone, for joining. My contact information is right here, and feel free. You know that number there. I just realized. Would the number on my questions is that number will get to me, but I just realized something. Let's do this. My cell number. So there it is. That's my cell number. So take a screenshot of that if you want.
All right, well, definitely thank you, Chris, for the wonderful presentation and for sharing your contact information. If anybody does have any questions, please feel free to reach out to the ISPE office or Chris directly. And thank you to all of you who joined us today, and we hope you have a wonderful weekend.
Great, thanks.
Thanks, bye.